With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so today's question is on the screen right now, and the question is: a given figure, a uniform cylindrical tube closed at one end contains a pallet of mercury 5 cm long. As you can see in the diagram, this is our air trap and this is our mercury pallet of 5 cm, and the height of air trapped is 30 cm. When the tube is kept vertically with the closed and downward, the length of the air column trapped is 30 cm, that is given in the question. Now the tube is inverted, that means inverted so that the closed end goes up. Find the new length of the air column trapped. Atmospheric pressure is given in the question, that is 75 cm of mercury. Assume temperature remains constant in the process. Now one diagram is given in the question. Now this is a case first that is given in the question. In case second, they said that they inverted the now our air pallet is here, our mercury pallet is here of same height, that is 5 cm. This is the air trapped, and we have to find out this height of air trapped. Okay, this is our mercury pallet. This is pattern second after inverted case second. Now as we can see that when we inverted this, the number of moles of air remains same. The air trapped in this column and the air trapped in this column is remains same. That means number of moles of air remains same. There is no change in number of mole. Now applying ideal gas equation, the ideal gas equation for case first. Okay, we are going to apply ideal gas equation for case first. P1 V1 equals to nRT. Let's assume that in case first our pressure is P1 and volume is V1 and temperature is T. And similarly in case second, our pressure is P2, volume is V2 and temperature is T2. Okay, so for case first, the ideal gas equation is P1 V1 equals to nRT. Now the number of moles are same, constant, universal gas constant, and in question it is given that temperature also remain constant. That means the whole nRT is remains constant. Okay, and for case second, we apply the ideal gas equation, that is P2 V2 equals to nRT. And for case second, the number of moles, universal gas constant, and temperature are constant. So from equation 1 and equation 2, we can say that P1 V1 is equals to P2 V2. Now putting the values, we will get. Now first we have to find out the value of P1 and P2. We have to find out the pressure, and the pressure is, just look at this condition, pressure, the pressure on mercury lead applied by atmosphere, that is P atmosphere. Okay, P atmosphere. So the pressure is coming in this, let's name it equation third. First we have to find out the pressure P1 and pressure P2. First we have to find out pressure P1, and pressure P1 is equals to P atmospheric pressure applied on the mercury plate, and the pressure given, that is just a second, Okay, so P1 is P atmospheric plus height of mercury pallet, that is 5, given in the question. Now our P1 is P atmospheric is given in the question, that is 75 plus 5, and it is 80 atmosphere of mercury. This is our P1. Now for P2, in case second, the pressure applied on mercury pallet by atmosphere, that is P atmosphere, in the reverse direction. Okay, so P2 is given as P atmospheric minus height. Okay, so P2 is 75 minus 5 is equals to 70 atmosphere of. Now we have pressure P1 and P2. Now putting the values and volume. How volume is given? V1 is equals to volume of cylinder is volume. We have to find out the volume, and volume is area into length. Okay, area into whatever the height is, that is given by this. For this, A into 30, and for this A into X, because we have to find out this thing H. So the volume in case first, it is area, that is A into height, that is 30 centimeter, and in case second, it is area into the height, that is X. We have to find out that. So the V1 is area into height, that is 30, and for case second, it is V2 equals to A into H, and we have to find out the H. Now putting the values of P1 V1 and P2 V2 in equations 1 and 2, we will get in equation 3. The equation 3 is P1 V1 equals to P2 V2. Putting the values, we will get P1 V1 equals to P2 V2. Putting the values, our P1 is 80 and P2 is 70. P1 is 80 into A into 30 is equals to 70 into A into H. A2 A cut. Now H is coming out as 80 into 30 upon 70. Calculate this, we will get the height comes 34.28 centimeter. Okay, so this is our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.